Development of the new McDonnell Douglas MDX helicopter, the most advanced commercial rotorcraft in the world, is moving ahead smoothly, paving the way for introduction of the versatile 21st century helicopter on schedule this year. And today, the MDX has a new name, the MD Explorer. It's an exciting name for a dramatic new product that is destined to map out a new course for the rotorcraft industry. McDonnell Douglas Helicopter Company and a team of leading international aerospace partners are working closely together to bring this innovative 8-place twin-turbine helicopter to the world market. The MD Explorer will pave the way in offshore, emergency medical service, executive transport, law enforcement, and utility markets. Although its first flight is still months away, customers in 20 countries have reserved delivery positions for 250 MD Explorer helicopters. These customers are convinced that the MD Explorer will set new standards of performance, availability, safety, and passenger comfort, and do it with lower direct operating cost and reduced noise and pilot workload. McDonnell Douglas Helicopter Company is committed to meeting those goals. McDonnell Douglas has explored and integrated new technologies that will offer customers a variety of features, including the revolutionary NOTAR system for anti-torque and directional control, a long-life bearingless flex beam rotor system that replaces conventional high-maintenance systems, and expansive visibility from a low-noise cockpit and cabin. MD Explorer teammates from around the world are hard at work designing, testing, and fabricating the individual components necessary for each helicopter. The fuselage for the MD Explorer, produced by Hawker de Havilland in Australia, and other structural components are being fabricated using space-age advanced composite materials. In fact, 39% of the new helicopter's fuselage will be made of composites. The engines have undergone a broad series of tests validating the superior performance promised to MD Explorer customers. In fact, the Pratt & Whitney 206A turbine engine was certificated for use in December 1991. Both the Pratt & Whitney 206A and Turbomeca Arias 2C engines chosen for the MD Explorer already have accumulated several thousand hours of testing, assuring customers that each engine will be able to apply more than 600 shaft horsepower in flight and do so at an acceptable operating cost. Kawasaki Heavy Industries in Japan already has delivered the first main transmission for the MD Explorer. Components are being manufactured using advanced robotic machinery, assuring precision and quality on this important helicopter system. MD Explorer will feature the most advanced cockpit display system ever installed in a production commercial helicopter. A first-generation prototype has been tested, and second-generation displays are moving ahead on schedule. The MD Explorer brings together all of these technological advances in one powerful package. MD Explorer will guide the rotorcraft industry into a new era and keep McDonnell Douglas positioned as the world's leading innovator and manufacturer of helicopters well into the 21st century. Come exploring with us. It's an adventure you'll never forget.
for a possible burglary in progress, 537 West Mariposa. Subject went in through the back window.
Hey, 16 Word Ridge, Mariposa.
Units be advised, one distinctive feature of the subject's apparel is one of them's wearing a gray sweater with a black striping around the end of the sleeves and the collar. 735, just the helicopter, there's an alley back there. Okay, yes, that was the front.
We're making a lot of catches out there. We've also done a couple rescues with the NOTAR, and we're learning the capabilities of it and some of the changes in the rescue program that we're going to have to make just for the new ship. It is very quiet coming in. A lot of times when we come in on a scene, the bad guys don't know we're coming. They can't hear us. Because most of our rescues are in tight places. There's been several incidents where the Bell 206 couldn't get in when we did the rescue. Years ago, Aerovac couldn't get in because their rotor system was too big. So we just like the tight, compact little machine.
You do not have a spinning rotor exposed for anybody to walk into or contact foreign objects, such as bushes, fences, what have you. The MD-520N, I think, is going to prove itself as one of the safer aircraft on the market and also one of the quietest aircraft on the market, which is going to aid the apprehension of criminals in our job. Now with the high technology, our arrest rate has already been increasing, especially with the increased light and the forward-looking infrared.
We're not as concerned now with the tail rotor, and we don't have to be worried about somebody coming up behind us. Being one of the first to be flying the 520Ns, being involved with the new technology, that's exciting in itself. If you would have asked me when we first started flying them, I would have given you some things that probably weren't positive, but the more I fly them, the more I'm getting to like them a lot better.
It's a quieter helicopter for our use. Much quieter. People on the ground say it's unbelievable. They don't know we're there until we're overhead, which is good for us and the citizens of Phoenix. There was a couple times when I first started learning to fly the 520N that I said, I'll take the D back, but not anymore.
NOTAR, you clear for taxi? Typically, a helicopter pilot's a slave to where the wind's from, but in the case of NOTAR, he really doesn't have to worry about where the wind's from because the workload is the same with the wind on the nose as it is the wind on the tail, or say crosswind from either direction.
These demonstration maneuvers we do today will show that insensitivity to the wind and also show that even at very extreme yaw rates and translation rates, the aircraft remains very easy to control for the pilot, or in other words, very low workload. The first maneuver we do here will be a yaw turn of 360 degrees to the left and right. And in fact, it's very easy to control the position, very easy to start and stop the turn. These yaw turns will peak at 100 to 120 degrees per second. First one will be left. Here's a full left pedal input. Here's the peak yaw rate and a full right pedal input to stop the turn. Now we'll look at one to the right. Here's a full right pedal input and a full left pedal input, and it's very easy to stabilize the heading again, and the pilot doesn't have to work very hard. Here's some right pedal inputs and stopping them after 90 degrees of turn. This demonstrates for the operational pilot how easy it is to start and stop the heading even using very high yaw rates. Now we're going to start some rearward flight to simulate a downwind condition. We'll take this out to about 40 knots, and again, this would be the equivalent of hovering downwind in about a 40-knot wind, and NOTAR is very easy to control in that condition. Now I'm going to do a rearward quick stop, and we'll get going the other direction. We're going to accelerate to about 60 or 70 knots here and pull the nose up to near 90 degrees. Once we get the nose up to about a 90-degree position, we'll put in a left pedal input and yaw around to the left and head down and back the other direction. Here's the nose up condition. Here's about 90 degrees, and left pedal input around and nose down. Now we'll accelerate back out to about 60 or 70 knots. And now at the other end, we're going to do the same maneuver, only to the right. We'll pull to the nose up to near 90 degrees nose up, and make a full right pedal input and yaw and point the nose down. For a helicopter pilot, the left pedal input is really the more difficult one, but NOTAR is easily controlled even in these extreme attitudes. Now we're going to pull up to high nose-up attitude and near a 90-degree bank angle and yaw in the direction of turn or do a skewed turn to demonstrate that NOTAR is easy to control even with very large yaw rates and bank angles. The thing about that maneuver is that's where a conventional tail rotor would go into a stalled condition and be very difficult to control. Now here's a turn in the opposite direction. High bank angle to the right and a high yaw rate to the right. Now as we come down on this pass at about 30 knots or so, we'll start a sideward flight condition which simulates a crosswind. And this is 30 to 40 knots. It's very easy to control and no real problem for the pilot. We'll now make a pass the other direction with the equivalent of a right crosswind. And again, at about 30 to 40 knots, we'll yaw to the right. And this is a good example of the ease of control and the heading control in a very extreme crosswind condition for the helicopter pilot. Now we'll do another rearward quick stop, and on this pass, we'll do a high yaw rate turn maneuver while we're translating over the ground at that 30 or 40 knots. It's a very difficult maneuver for a conventional helicopter. In fact, in NOTAR, it's fairly easy. Here's the turn starting, and again, we're translating at about 30 to 40 knots, and the yaw rate here will be peaking at around 100 degrees per second. Now we'll do a rearward quick stop and repeat the maneuver in the opposite direction. This will be left turns at that same speed. This is a very extreme maneuver for a helicopter with a conventional tail rotor. In fact, the tail rotor sometimes stalls during this maneuver. But in NOTAR, it's very easy to fly, and it's easy to maintain your altitude and keep the helicopter going down the center line, which would be virtually impossible with a conventional tail rotor or a finistron in that same maneuver. Now we're going to accelerate back down the runway at the same speed and do some 180-degree turns to show the capability to change direction rapidly and stop it, because it's a very controllable condition when we move down the runway in order to yaw in and out of the wind, which again is a difficult maneuver with a conventional tail rotor. Now we'll stop and reverse direction and do the same thing in the opposite direction. Here's the 180-degree yaw, nose left. And we'll stop it in rearward flight, or the equivalent of a downwind, and now we'll yaw back nose right. Now we'll do a nose right yaw into rearward flight or a downwind condition. And now we'll yaw back into the wind. And you can see it's very easy to control the heading precisely, even though these are very high rate maneuvers at this 30 to 40 knot airspeed. We're going to transition now to a pirouette maneuver where we yaw and translate the helicopter at the same time. We're about 25 knots. Now we're starting to yaw, and we're at a sideward translation. And now we'll yaw about a point in front of the nose, and I'll try to keep the H right in front of the nose. It's a difficult coordination maneuver in a typical helicopter, but you can see once I establish the yaw rate in the translation, it's very easy to keep the nose on the point. Now we're going to land, and I'm going to set the pedals at a typical hover pedal position in order to demonstrate NOTAR's lack of requirement for pedal inputs with large power changes. I've got about a 1-inch of left pedal here, and the first thing we'll do is pick it up into an in-ground effect or IG hover without making a pedal input. And there's no directional control augmentation on this helicopter, so as long as the pedals aren't moving, there's no input to the directional axis. Okay, here we are picking it up off the ground, first into a low hover, and there's no wind today, so the aircraft may weather vane a little bit. That's all we've got here is a weather vane, and it'll yaw a small amount as I make the power changes, but you'll see that that pedal position is good essentially no matter where I put the power in this hover condition. Now we'll increase power to max torque, or the red line, in a vertical climb, and you'll see that even with that large power change, once the heading settles down, that pedal position is good for this new power. Now we're going to establish a high hover or an out-of-ground effect hover at a different power setting than we had at a low hover. And you can see, even with the power changes, the heading does not change very much. Now we're going to translate to the right and accelerate out to about 50 or 60 knots. You can see as we begin to accelerate, the helicopter yaws in the direction of travel. And now we'll do a quick stop where the power goes to the minimum. Right here we've got the power on the bottom, and I'm rapidly transitioning back into a hover again. And I have to pull power rapidly back in right here to establish an OG hover again. All that without a pedal input is significant because typically that's a very high workload maneuver for the helicopter pilot.
The workload remains very low. In fact, in this case, with my feet on the floor, the pedal workload for the pilot is 0. And those are all characteristics of the NOTAR system that allow me to do that. And in fact, obviously we're not advocating flying helicopters without any directional input by the pilot through the pedals. But what we have seen is that by eliminating a lot of the directional workload, the helicopter becomes much easier to fly.
While helicopter deliveries are fairly routine for us, this one is historic for our company, the helicopter industry, and for the Phoenix Police Department. For the company, it represents a major milestone in technology development and culminates more than 15 years of work by hundreds of dedicated men and women.
The citizens of Phoenix approved us purchasing 7 new helicopters to replace our fleet that was getting quite old. You, at least in our mind, expedited that process and allowed us to be the first organization to receive this new advance in helicopter technology.
Since he learned to fly, man has continually sought to improve upon the technology that first freed him from the yoke of gravity. In vertical flight, such improvements have included the turbine engine and the use of lighter composite materials in manufacturing. Now comes another, destined to reshape the future of rotorcraft. McDonnell Douglas Helicopter Company introduces a revolutionary breakthrough in rotorcraft technology, the NOTAR, No Tail Rotor System. The tail rotor, which provides anti-torque thrust and directional control, has been a familiar feature on most helicopters since they first took flight. But the tail rotor also poses a hazard to air crews and those on the ground. What's more, it's noisy and adds to the pilot's workload. By replacing the tail rotor with the NOTAR system, such hazards and pilot workload are greatly reduced. Pilot workload drops because, unlike a conventional helicopter, it takes the same amount of effort to hover a NOTAR system-equipped helicopter downwind as upwind. The technology that makes all this happen is deceptively simple. It consists of an enclosed fan driven by the main transmission, a circulation-controlled tail boom, a direct jet thruster, and vertical stabilators. Low-pressure air, forced through two tail boom slots, makes the main rotor downwash hug the boom's contour, creating a lateral lift that counteracts most of the main rotor torque. The thruster, in turn, provides directional control. The result? Anti-torque directional control with improved safety, prolonged life of aircraft components due to less vibration, reduced maintenance, less noise, and lower direct operating costs. What's more, potential loss of tail rotor effectiveness is greatly reduced because the fan's inside the tail boom, where it's unaffected by external influences. With its new family of NOTAR system-equipped helicopters, McDonnell Douglas vaults to the head of the pack in the use of lightweight, durable composite materials. Composite parts increase payload and reduce direct operating costs by lowering aircraft weight and extending the service life of components. The NOTAR system is now available in the newest versions of McDonnell Douglas's popular MD-500 series, the commercial MD-520N and 530N helicopters. The military version of the MD-500 series, the combat-proven Defender, is also now in production with the NOTAR system. Looming on the horizon is the light commercial helicopter, the twin-turbine 8-place MDX. The versatile MDX will transform easily into an executive limo, personnel transport, or cargo carrier, depending on need. The future in rotorcraft is here. Its name is NOTAR system. It will forever change the way we think about helicopters.